So hello, my name is Gabriel Brown. I'm an industry analyst with Heavy Reading, and I'm here in our London studio talking to Jan Mertens, who is head of R&D at Ericsson Antenna System, over in Ericsson's Kista studio. Welcome, Jan. Great to see you.
Welcome. Thank you.
So we're here to talk about antenna systems, of course. This is a really key, it's really the edge of the network and where your phone signal first touches the network. I know you guys have been doing a lot of work on product innovation, technology innovation. Just talk to us a little bit about how innovation in antenna technology actually impacts the end user, the customers like myself and all of us.
Yeah. So there are actually lots of different touch points. The most obvious one is you want to have a good signal, you want to have good coverage. And that's what we are then doing when we are innovating on how we are designing these antennas to make sure that we cover the full cells, don't have interference. And most of the time, actually, as an end user, you don't really notice that. What you mostly notice is your device is again out of battery. And that could be, for example, because of interference. Yeah? And we had a case where we, in a real network, swapped an antenna and then showed that we improved the link between the phone and the antenna so that we reduced the battery usage of 35%. And that's quite significant. And that would be something that you then directly use besides all higher downloads or faster uplinks.
Yeah, I think it is important to think about how network technology just becomes, it's invisible, but actually people do notice it, the frustration or the battery or whatever you're talking about. Obviously, you're talking a bit there about uplink and things. Just illustrate how the antenna improves uplink.
Yeah, so there are multiple ways we do that. So uplink in general now is much more important to talk about because in the past we typically downloaded lots of content, and now we are creating more content and uploading it. And here it's for example important that you have a really good PIM efficiency of your antennas. PIM is short for passive intermodulation, which essentially creates noise in your receiving channel in the antenna, and you don't want to have that. And when you do that, and also that's something we've shown in a live network, you can really boost uplink. So something like 30% with our latest honeycomb design. That is what you then get as a better connection towards the network when you are uploading content.
Yeah, I think if there's one thing, there's a few really key things, but improving uplink's going to have a huge impact. I mean, all operators want that, and so that's great to hear. Tell us a bit then about how you optimize for system efficiency and also beam efficiency. They're kind of related, but just talk us through.
Yeah, so we kind of have a new design philosophy, which we call try on net. And here we start really with thinking about the network first. What is the impact that we want to generate in the network? And then we are having multiple dimensions in our antenna that we are optimizing. That's the overall antenna design. And then very importantly, the three-dimensional pattern of the antenna. So not only really focusing on a data sheet, but making sure that the radiation pattern of the antenna, one of these I have in my hand here, is optimized so that we get the full system level performance of the antenna to really have the impact that we want to have in the network. And we ensure that by starting off with actually a digital twin of the network, and then we place into that digital twin digital twin of our antenna, and then work with all the different parameters you might have in such a pattern here to optimize it so that you then really get the performance that you want for your network and not only on the datasheet.
Okay, so good. So then also talk about how you're sort of link R&D and the work you do, I guess, in your department with product design and sort of manufacturing as well. There's a kind of a three-stage link there.
Yeah. No, so it's super important. As I said, we have this simulation, the digital twin, and there we can then nicely work all the design parameters. But already in the early stages, you need to make sure that the antenna can also be manufactured at scale, right? And that's why we decided already quite a while ago that we want to bring industrialization, anything that is about how do we design for mass production, very close to R&D, actually very close to the very beginning of the design cycle, and that's then the system development. Yeah? So that we really have a very close connection between there is a systems architecture generated and how do we produce that, and the other way around. And for us, this became really instrumental. Now, in the past, it was often that we got requirements, maybe wishes from our customers. Then we developed an architecture and a design of the antenna, and industrialization had to make sure that it goes into the factories. And now, since this is much more closely linked, anything we are developing in the industrialization area suddenly becomes an innovation driver for us. And we can think antennas completely differently. And that becomes like an innovation flywheel, really.
Yeah, that's really interesting. I think it's probably fair to say in the past in the industry that part of the process has got a bit elongated and abstract from each other. So that's a super interesting way of looking at it. When you put these latest generation antenna out in the field, what are some of the types of gains you're seeing relative to, if you could baseline that to, I don't know, your previous generation product or an industry standard baseline?
Yeah, so there are multiple different ones. So let me start. I talked about passive intermodulation before. What we've done there for the first time actually in the industry is that we did a trial in a live network where we compared an antenna with standard PIM level and then swapped it out to our honeycomb superior, PIM superior design. And with that, then we showed that uplink and also the coverage was increased by 30%. So that's one example. Another one is we had a customer that was facing challenges with energy consumption. So we swapped out antennas that were in this network with our latest antennas, and then could show that we, on the one hand, improved the performance of the network, but most importantly, really the energy the radio uses was reduced by about 30%. And that then is really significant for the operators, right? Because it directly translates into the running cost for having your network up and live.
Yeah, good stuff. Pretty decent numbers there. So you talked about bringing R&D and industrialization close together. Tell us a bit about, where you're thinking the next steps are in your kind of R&D journey. Of course, we know we're not going to get all the secrets, but just give us a little hint as to kind of where this is going over the next few years.
Yeah, well, what we are obviously always striving for is having antennas more efficient. So that's kind of relating to the last bit I mentioned. So the higher the antenna efficiency, essentially the more signal you can put through from the radio side to the antenna and radiate it into the network, the lower energy the lower energy usage you have in your network. That's a key topic also from a sustainability point of view, cost of running the network. So that's something we are continuously working on. And as I said, because we have this very close link, any industrialization or production methods now become a tool for us to think antennas differently. And we then suddenly can start using very new materials that allow us, for example, to have better efficiency of the antennas. Another topic then really crucial for us is to design the uplink or more to say the beam efficiency in the right way, so that we direct the energy that is coming from the antenna in exactly the right cell and don't have overlap to other cells where you then create interference and then have poor network quality. And also this is a focus topic where, again, this close link between industrialization and the system design comes into play, because we can then design radiators in our antenna very differently, can play around in a different way with the array and then the signal distribution in the antenna, which is really interesting. If I looked out more into the future, there are some very interesting, well, let's say, thought games or also visions out there. For example, not having antennas, at least in like metropolitan areas anymore, as these boxes, we know them on roofs, but more as distributed panels. And there we are looking then also into completely new materials that are today not used in the antenna production. And then how can we interlink that with radiating elements, signal distribution elements? So there is quite some cool stuff coming in the future.
Hey Jan, great to hear we have a good amount of runway in antenna innovation to come. Thanks very much for joining us.
Thank you so much for having me.